Welcome back. We're going to do example 7.3.2, the last example in section 7.3 on joint distributions. Gasoline at a service center is stored in a huge tank. The tank is refilled at the beginning of each week, but not necessarily due to capacity due to varying supplies. So we're going to let X be the proportion of the tank that actually gets filled. And we're going to let Y be the proportion of the total capacity. So the total capacity, not the amount that's filled, but the total capacity of the tank that is sold in a week. The joint density function, or probability density function, or PDF, the joint density function for X and Y is given here. And so we're asked to draw the support of X and Y in the XY plane. So the support of X and Y is going to be the set of all values that the pairs X and Y can take, and so that is given to us here. And we can look at this and see if this kind of makes sense. Well, these are proportions, right? X is the proportion, so proportions are between 0 and 1. You can't have a proportion larger than 1 when you're talking about filling a tank, or you'd be spilling your gasoline everywhere. And Y is the proportion of the total capacity that's sold, right? So if only X gets filled, we can't sell a proportion larger than we have. So it makes sense here that Y is less than or equal to X. Now, if we take this, which is written as a single sort of inequality in a string, we can rewrite this as 0 is less than or equal to X is less than or equal to 1, and 0 is less than or equal to Y is less than or equal to X. And then, lo and behold, we know what this region looks like. That is one of our type 1 regions that we can draw easily in the plane. So let's give ourselves a set of axes here. Here's my X axis. Here's a Y axis. And we are looking here to have X go from 0 to 1 and Y go from 0 to X. So I need the line Y equals X here, and we're going to reach up to this point, and X, right, X will go from 0 to 1 along here, and Y will go from 0 to X, right? This is the line Y is equal to X. And so the region that we are looking for is this region inside the triangle here. So let's fill that in. So there is the support. Now the next questions are going to ask us to do some calculations. Let me fill this in. This is lagging a little bit. That's strange. There it is. Okay, so the next question says find K. K is right here. And so we are going to use the property that the integral over all values of X and Y of the density function has to equal dx dy or dy dx. It actually doesn't matter what order. I'll write dy dx. dy dx has to equal 1. Now this looks like it's going to be an improper integral, but a lot of this is 0. And so we can actually, if we call this our region D, we can actually rewrite this as the double integral over d of f of xy dy dx has to be dy dx has to be 1 because outside of d we're going to get 0. So this is the integral from 0 to 1 on the x and the integral from 0 to 1 on the y, and our density function is kx, and this is 0 to x I just said, and the order is dy dx, and so that has to give me 1. And so this is just a plain old double integral that we are comfortable with now. We're going to integrate with respect to y, so we're going to get kxy that goes from 0 to x. We'll run that dx, and that's all equal to 1. So we're having the integral from 0 to 1. We get kx squared minus 0 dx, which is going to give us k times x cubed over 3 from 0 to 1. That has to be equal to 1. And so we get k times 1 cubed minus 0. So k over 3 has to be 1, or k is equal to 3. Next question. C, find the probability that the tank will be filled less than halfway. So x was the proportion that the tank got filled to, so that's that x is less than or well, strictly speaking, less than is just without the equal sign. X is less than 1/2, and more than 1/4 of the capacity will be sold. So Y is greater than 1/4. So we are looking for the probability that X is less than 1/2 and Y is greater than 1/4. And with these questions, the real challenge is translating this or this into well, first of all, translating the text into probability symbols in terms of X and Y, and then translating that into the region that we want to integrate. So if we take our support here, if we take our support and let's bring that down here, if we want X to be greater than 1/2, well, let's go and add that in here. So X is 1/2. And so everything over here is when X is, except I don't want it greater than 1/2. You'd think I'd learn these symbols. Now X, I want less than 1/2. There we go. So X being less than 1/2 is everything sort of in here. This is when X is less than 1/2. We also want Y to be greater than 1/4. So this is the point up here, right? If this is Y equals X, that's 1, 1. And so we're looking about 1/4 of the way up. So somewhere here-ish, 1/4, we want Y to be greater than 1/4. And so for Y to be greater than 1/4, we want everything in here. Y is greater than 1/4, and so that's everything in the green triangle. Except we want those to be true at the same time. We want and. Remember, the way of thinking about this comma is as an intersection. And an intersection of these two regions gives me that triangle there. So that is the region of integration. That is the set that I want to integrate over to get these probabilities. So let's describe that set properly. We have X, so again, if this is the line Y equals X, then this is 1/4 as well. And this is the point 1/2, 1/2. So we are looking to integrate over the set where 1/4 is less than or equal to X. Well, again, strictly speaking, we had less than, but it doesn't matter. And less than 1/2. And Y is going to go, well, Y is going to go up here. And so Y is 1/2 is less than Y, and that will stop at X. I keep wanting to write less than or equal to. It doesn't matter, but let's try and be precise. So that's our region of integration, which means that we are going to set up a double integral over this region. So we're going to have the integral from 1/4 to 1/2 of the integral from 1, again, I'm not paying attention. 1/4 was the Y. 1/4 to X of our density function, which was K, but we found that K was 3, of 3x dy dx. And that is the toughest part about this, is translating this text into these symbols and into the correct integral. Once you know that, well, then it's just a matter of evaluating that integral, and that I did for us off screen. If you want to check, you are certainly welcome to, but that gave me 5/128, which is the probability that we end up by landing in this little region, the probability that the tank is filled less than halfway and more than 1/4 of the capacity is sold.